I'm going to leave Haber and contact, except I've already talked about Haber already. Equilibrium and Le Chatelier we've now covered. As long as you understand that principle, then we're fine. Now, what about Kc? Calculating Kc in units of Kc. Well, the equilibrium constant. This is the equilibrium constant in terms of concentration, but that's the only one just for normal equilibrium you're going to have to worry about. What is the equilibrium constant? Do you remember?
Over concentration of reactant.
Yeah. So that's our example again with the Haber process. That is the equilibrium constant. So you need to know how to write the equilibrium constant for any reaction you're given. Now, the equilibrium constant that's the whole point. It is a constant, and that's what I'm talking about when I talk about Le Chatelier. That the driving force behind Le Chatelier's principle is the fact that this value, Kc, remains constant. Constant when? At the same temperature. So equilibrium constant is constant. You need to write this down, it's very important. Kc is constant at a constant temperature. But the value of Kc will change if you change temperature. Okay, so it's very important that you remember that. So Kc is a constant at constant temperature. Now Kc has units always, because you've got units of concentration on the top and on the bottom. And once again, and this is a very important point, of course, following on from last week. Do you remember last week I said, how do you find out the rate equation? How do you find out a rate equation? Experiment, thank you. Experiment. You have to do an experiment to find the rate equation. You can't guess it, or you can't get it from the stoichiometric equation. You can't get the rate equation from the stoichiometric equation. The only way is to do an experiment and see how changing the concentration affects the rate. Okay. But the equilibrium constant is quite different, because the equilibrium constant is always found by looking at the stoichiometric equation. So don't confuse those points. So the equilibrium constant has units. So all we have to do is we say, right, we've got moles. This is all units of concentration again, of course. So we've got moles per decimeter cubed squared on top. Yes, you're all with me here. And on the bottom we've got moles per decimeter cubed to the 4, haven't we? 3 plus 1. Yeah, remember indices, if you times them, you add them. So what we've actually ended up with is we end up with 1 over, because we can cancel 2, can't we? We end up with 1 over moles per decimeter cubed squared. Yes? And so what will happen here is we will bring those to the top, but it's squared, so it's moles to the -2, decimeters to the 6. So those are the units for Kc. Now you need to be able, in this particular example, you need to be able to calculate those units for any equilibrium constant. If you really can't do that, you can learn what the units will be, can't you? Because effectively, if you've got one concentration term on top and one on the bottom, what will the units be? No units. Don't forget that, and you need to write it in. If you have 2 concentration terms on the top and 2 on the bottom, it's no units. If you have the same number of concentration terms on the top and bottom, it's no units. But you can also work out if you have 1 more on top or 1 more on bottom, what the units will be. You all with me?
Yeah. How would you express, like, if you're writing an answer of something like the top and bottom the same, would you just say, give the answer?
No units. You write no units. That's what you do. Okay? So you say Kc equals 24.3 no units. Okay. Now actually you don't have to do that in real life, but in your exam it's a good idea, because it tells the examiner that you know exactly what you're doing. You haven't missed the units out, you've put them in because there aren't any.
It's a bit odd.
It's very odd. Right, so that's it. Now, what about calculating Kc? Now, people get a bit confused with calculating Kc. So, what they do is what you need to do with calculating Kc is you need to remember that you have to have, you have initial values and then you have final values.